Hi, welcome to lesson 29. In this lesson, we're going to be working on word problems that lend themselves to linear systems of equations. So we'll be defining variables and writing up equations and just seeing how two equations can help with lots of problems and lots of situations. So these are kind of fun. I hope you'll find them fun. There are multiple ways to solve these problems, so we're looking for efficient methods. So let's look at example 1, and you have this in your notes. So the sum of two numbers is 361, and the difference between the two numbers is 173. What are the two numbers? Okay, so I'd like you to just try to work on that problem and see what you can do to solve it, and then come back and we'll talk about the problem some more. So go ahead and pause now and work on that. Okay, so you may have come up with a solution for this problem, and I'm going to walk you through the steps now of how to solve this using a linear system of equations. So when I look at a problem like this, my first step would be to define the variables. And so I notice that I've got two numbers, and I'm needing to figure out what the two numbers are. So I could have two variables here. I could let x be one number, and I'll let y be the other number. Okay, and so if that's what x and y are, I can look at the problem and begin to write it in mathematical language. So the sum of two numbers is 361. So I have the sum of two numbers is x plus y, and I know that that equals 361. And the difference between the two numbers is 173. So x minus y is equal to 173. The difference between the two numbers is 173. What are the two numbers? So I have two equations here, and I have two variables, and that's kind of what a linear system of equations, the ones we've been solving in the past several lessons, look like this. So we could ask ourselves, what would be a good way to get started finding a solution to this? And I want to make sure I have my notation on there too. So think about what could be your strategy for finding a solution. So for this one, because we can notice that the y terms have opposite coefficients. So I've got a positive y and a negative y. So I can use elimination to get to my next step. So I would have, adding the left-hand sides, I would have x plus y plus x minus y is equal to the sum. So the sum of the left-hand sides would have to equal the sum of the right-hand sides. So it's 361 plus 173. So when I can notice here I've got plus y minus y. So I can see this is 2x, because it's x plus x. 2x is equal to this sum right here. So I've got a 4 and a 13 and a 3, 4, 534. So then dividing both sides by 2, I'm going to get x is equal to 267. So one of the numbers, and when I solve for a variable, I always like to go back. X is one of the numbers, so how can I find out what Y is? Well, I could just plug 267 in for X in either of these equations. So I can plug it in right here and find out that 267 plus Y will equal 361. So Y is equal to 361 minus 267, which is 94. Okay, so our solution here, the two numbers, are 267 and 94. Okay, their sum and their difference. Now, in this case, does it matter? Did it matter which one was X and which one was Y? Well, not really, because they're two numbers, but for this equation to have made sense, X had to be the bigger number. So, but I don't need to know that when I'm writing them. The solution will just kick that out. Okay, so there's example one. There's a good example of this problem could have been done maybe by guess and check, and just kind of using your number sense. But with a linear system, the answer just pops out. All right, let's look at another example. There are 356 eighth grade students at Euclid's Middle School. 34 more than 4 times the number of girls is equal to half the number of boys. I don't know who figured that out. That's kind of a weird problem. But anyway, how many boys are in 8th grade at Euclid's Middle School? How many girls? Okay, so again, the first step is to define the variable. Or variables. Okay, so we want to define those. So we need to look back at the problem and see what we need a variable for. So we've got some students, and now we're talking about boys and girls. So how many boys we're asked to find, how many girls. So we could let X be one of those. We'll let X be the number of girls, and let Y be the number of boys. Okay, so now that we have variables defined, we can begin to write down in mathematical sentences what we know. So one of the things we know, the first thing we know, is that there are a total of 356 8th grade students. So we know that the number of girls, X, plus the number of boys, Y, is equal to 356. So that's one of the things we know. But if we didn't know, if that was all we knew, we wouldn't be able to tell how many were girls and how many boys. That kind of makes sense, right? Could be anything. So we're given this other statement over here about 34 more than 4 times the number of girls is equal to half the number of boys. So I have to think about how to represent that with an equation. So I'm going to work on 34 more than 4 times the number of girls. Well, 4 times the number of girls would be 4x. X is the number of girls. 4 times the number of girls would be 4X. 34 more than 4 times the number of girls would be plus 34. Okay, and we're told that 34 more than 4 times the number of girls is equal to something. So I can put is equal to down in my sentence, is equal to half the number of boys. So this would be 1/2 Y. Okay, and so since we need both of these pieces of information to come up with a solution, I'm going to put the brackets on there to show that this is a system of equations, not just a single equation. All right, so you can look at this and using what you've done in the past few lessons, see if you can solve this. So go ahead and pause it and see what step you would take. Okay, so as I look at these equations, I notice that this second one has the y variable isolated. The only problem is it's got the 1/2 there. If it was y equals something, then I could just put it in for y up here and then solve for x. So that's what I'm going to do. And so I just have to take one step before I can do that. If I multiply both sides of this equation by 2, then I'll have, I'll get y out of that. So this is 4x plus 34 is equal to 2 times 1/2 y. So this is going to give me 8x plus 2 times 34 would be 68 is equal to y. So now I have an equivalent equation, and I'm going to use this to substitute right in here. And so I can substitute, so this is x plus y is equal to 356. So instead of y, I'm going to put in 8x plus 68. Because that's equal to y. It's the same thing. So now I can simplify this, and I'm going to have x plus 8x, which is 9x, plus 68 is 356. Now you could have done this different ways, right? This is just my choice of way. 9x is equal to whatever that is. Let me figure it out. 288. And then we need to divide both sides by 9. Okay, and I know this is divisible by 9 because the digits add up to 18. So 288 divided by 9 gives me 3, 27, 18, 2, 32. So x is 32. Okay, so once I know the number of girls, so the number of girls is equal to 32. Now I can figure out the number of boys easily because it will be 300 and I can plug into x plus y equals 356. So the number of boys will be 356 minus 32. 324. So the number of boys is 324. And the number of girls is 32. And if we want to check our answer here, we know that it fits with the first equation, x plus y equals 356. We might want to check it with this equation. So we'd go 4 times 32 plus 34, and ask myself, is that equal to 1/2 of 324? So you can do that check and make sure that this is a solution to our equation right there. Okay, it's always a good idea to check your work on these. All right, let's look at another example. Example 3, a family member has some $5 bills and $1 bills in her wallet. Altogether, she has 18 bills and a total of $62. So how many of each bill does she have? So I have $5 bills and $1 bills. So we need to define a variable. So let's let X be the number of $5 bills, and let Y be the other one, be the number of $1 bills. Okay, so at this point, when I'm defining my variables, I could have gone either way. I could have let X be the $1 bills and Y be the $5 bills. But since I've defined it this way, I'm going to write my equations accordingly. So it's going to be important now which is X and which is Y. Same was true in the last example. Okay, so altogether she has 18 bills. So altogether she has 18 bills and a total of $62. How many of each bill does she have? Okay, so she's got X number of $5 bills and Y is the number of $1 bills. So she has 18 bills altogether. So what does that mean? That means the number of $5 bills plus the number of $1 bills is 18. She's got 18 pieces of paper altogether. She has a total of $62. So how am I going to express the amount of money she has using my variables? Think about that for a minute. Okay, so if she has X $5 bills, then the total amount of money she has in $5 bills would be 5 times X. So for instance, if she had 2 $5 bills, then X would be 2, and she would have $10. 5 times 2 is $10. So any number, if she had 10 $5 bills, 10 times 5 is 50. That would be the amount of money in $5 bills that she had. Okay, so Y is the number of $1 bills. So the number of bills is the number of dollars there. So my total dollars would be 5X plus Y, and I know that my total is 62. So how many of each bill does she have? Well, if I solve this system of equations, then I'm going to be able to figure that out. So let's look at this one. What would be a good method for solving this? Again, there's different ways that you can solve this equation. I'm going to take this first equation and multiply both sides by a -1. That will give me a new equation, which will be -x minus y is equal to -18. Okay, and so that gives me a new system right here, these two equations right here. So now I'm going to add the left-hand sides, and I'll get 5x plus y plus a -x, and I'm going to put plus a -y is equal to 62 plus -18. Okay, so I've got, over here I've got the positive y and the negative y are going to become 0 together. Positive 5x and negative x is 4x. So I have 4x is equal to 62 plus negative 18, which is 62 minus 18, or 44. And so x, I can see, is 11. So what does that tell me? If x is 11, then she has 11 $5 bills. If she has 11 $5 bills, then she must have 7 $1 bills. So let's double check our math here. That's 18 bills altogether, and I would have $55 in $5 bills plus 7 in $1 bills, which is equal to $62. So that does check out. Example 4 says, a friend bought 2 boxes of pencils and 8 notebooks for school, and it cost him $11. He went back to the store the same day to buy school supplies for his younger brother. He spent $11.25 on 3 boxes of pencils and 5 notebooks. How much would 7 notebooks cost? Okay, so I want you to reread this and start sketching out how you think you would define your variables, and maybe start to write equations as well. Okay, so it's always a good idea to reread these, and especially reread what it is you're being asked. I need to know how much notebooks cost. So that's definitely going to be a variable, the cost of a notebook, of a single notebook. But notice it's all tied in with, the cost of notebooks is tied in with the cost of boxes of pencils. So I'm going to actually still have 2 variables. So I'm going to let x be, we'll let x be the cost of a box of pencils. Whoops. The cost of a box of pencils. And we're going to let y be the other cost that we know about. And this is actually the one that we need, the cost of notebooks. Okay, so if x is the cost of a box of pencils, y is the cost of a notebook. We'll say a notebook. Oops. Okay, so once I have that done, I can begin representing the information in the problem as a mathematical sentence. So a friend bought 2 boxes of pencils and 8 notebooks for school, and it cost him $11. Okay, so here's a piece of information I know that I can use my variables to write. So 2 times the cost of a box of pencils would be 2 times x, plus 8 times the cost of a notebook, if I can get 8 notebooks, and 2 boxes of pencils for $11. Okay, but I've got more information than that. I know that if I buy 3 boxes of pencils, so 3 times the cost of pencils, and 5 notebooks, so 5 times the number or the cost of a notebook is $11.25. 3 pencils, 5 notebooks, yeah. Okay, so now I need to look at this system and decide what strategy I want to use to solve it. Unfortunately, the coefficients are all different. I've got 2 and 8 and 3 and 5. They're all different, but I can eliminate one of these variables and solve for the other one. Okay, so I could go either way. I could either eliminate x or y. I'm going to choose to eliminate x. And so what I want to do is get write equivalent equations so that the x, the coefficient of the x terms are opposites of each other. So if I multiply this equation through by 3, then I'll have 6x here. And if I multiply this equation through by -2, then I'll have -6x here. So let's look at what this looks like. So I'm going to multiply this first equation, multiply both sides by 3. And I'll have 6x plus 24y is equal to 33. And then I'll take this one here and multiply by -2. -2, both sides. This gives me -6x minus 10y is equal to -2 times that, which would be -22.5 or 50. Okay, so now I've got these two equations here, and I'm going to add the left-hand sides and put them equal to the sum of the right-hand sides. Same thing we were doing in these other equations. So we would have 6x plus 24y plus -6x plus -10y is equal to 33 minus 22.5. Okay, so I'm going to give myself some room here now. So let's simplify that. So 6x and -6x is 0 together. 24y minus 10y is 14y. So I'm going to end up with 14y is equal to 33 minus 2250, which is 10.5. 33 minus 22 would be 11, minus the 0.5 would be 10.5. So now divide by 14, and y is equal to, this actually comes out to 0.75, which is also 3/4. Okay, so I know what my y is. So what is, let's go back. Y is the cost of a notebook, and it's in dollars, right? Because we've been using $11 and $11.25. So I know that the cost of a notebook is 75 cents. But that's not what the problem is asking me. The problem is asking me how much would 7 notebooks cost. So, 2 things I might want to do here. One thing I should do is go back and check. I could go back and find out what would the cost of a pencil be by taking 0.75 and plugging it in here to find out what the cost of a box of pencils would be. And then I could check it in the next equation to make sure that it's correct. So that's an important step to do, and it's one that I'm going to skip right now. I'll let you do that. You could find out the cost of a box of pencils, even though we don't need to know that to actually answer the question, and then you can check your answer. Okay, so 7 notebooks would cost 7 notebooks cost 7 times 0.75, which is going to be $7.25. No, it's not. That's not right. It's got to be less than $7. So this is $5.25. Okay, so 7 notebooks cost $5.25. So that is my solution. Okay, now you get to sit in the driving seat and work on these next 3 exercises. So you've got exercises 1, 2, and 3. And see how you do on those, and then come back and check your answers, and I'll walk you through them to make sure you're getting it. Okay, so go ahead and pause and work on exercises 1 through 3. Okay, so this first one is a fun one. A farm raises cows and chickens. The farmer has a total of 42 animals. One day he counts the legs of all of his animals and realizes he has a total of 114. How many cows does he have? How many chickens? Okay, so not exactly a real life problem, but it is a fun puzzle. And you could solve this by guess and check. You could. It might take you a little while. And maybe it wouldn't, but you can also solve it with a system of equations. So again, make sure you define your variables. I'm going to let x be the number of cows, and I'm going to let y be the number of chickens. Okay, so the farmer has 42 animals. So what do I know? I know that the number of cows plus the number of chickens, y, equals 42. Okay, now I have to write an equation based on the number of legs of all of his animals. So the number of legs is 114. So cows, 2 legs, cows 4 legs, chickens 2 legs, sorry. So I would have the number of legs that come from cows would be 4 times the number of cows. For every cow, there's 4 legs. So this is going to be legs here. So that's legs of cows. Legs of chickens would be 2 times the number of chickens. And if I add those together, I would have 114 legs altogether. So now I have enough information to solve this equation. So let's see, what do I want to do? I'm going to multiply through by -2 on this first equation here, -2 and -2. And so I'm going to get -2x minus 2y is equal to 84. Okay, so then I'm going to combine these two equations here, and I'll have 4x. So I'm using elimination here. 4x plus 2y minus 2x minus 2y is equal to 114 plus negative 84 or minus 84, however you want to think about it. And so simplifying this part, the left-hand side, 4x minus 2x is 2x. 2y minus 2y is 0, so that's doesn't figure in. So now I need 114 minus 84. So I think that should be and so dividing through by 2, I get x is 15. So there are 15 cows. And if I want to solve for the number of chickens, I'm going to have x plus y is 42, so 15 plus y equals 42. So I need to take 42, subtract 15, and I'm going to get 27. So y is equal to 27. So there are 15 cows and 27 chickens. Okay, and if I want to check that, I need to go back to the second equation over here, the one that was counting the legs. 4x plus 2y equals 114. So 4 times 15 plus 2 times 27 is, and I'm asking myself, is that equal to 114? So I get 30, or no, not 30, 60 plus 40 and 54 is equal to 114, and it is, so that checks out. Okay, so this works right there. Okay, number 2, a little bit of geometry here. So the length of a rectangle is 4 times the width. The perimeter of the rectangle is 45 inches. What is the area of the rectangle? So if you haven't done this one, pause, but if you're checking, just continue on. Okay, so we want to define variables. We need to find the area of the rectangle, but in order to find the area, we need to know the length and width. And so those would be our variables. So we're going to let x be the length and let y be the width. Okay, and I could have done it the other way, but my equations would look different if I defined it the other way, x and y being backwards. I could have used L and W, but I find that L's don't work very well. They get mixed up with numbers in equations. So x and y work really well. So this x is going to be the length, y is going to be the width. So I can begin to write some equations with the information given. So let's look at this one right here. The length is 4 times the width. So here I go. The length, which is x, is equals 4 times the width, which is y. X equals 4y. So it's right here. X equals 4y. The perimeter of the rectangle is 45 inches. So I can write that some different ways, but to find the perimeter, I'm going to do x plus y plus x plus y. that would be my perimeter is equal to 45 inches. Okay, so I've got, let's rewrite the system up here. I've got x, actually I can do it over here. X equals 4y, and 2x plus 2y is equal to 45. Okay, so let's see. I'm not sure how you did this one, but I think substitution would work really well because I'm going to put this down here. X equals 4y, and here's my system that I'm working with now. So if x is 4y, that means I can write this equation. 2 times x plus 2 times y is equal to 45. And once again, x is equal to 4y. So instead of putting x in here, I can put 4y in there. And let's move back up to the top here. So this gives me 8y plus 2y is equal to 45. So 10y equals 45. So dividing both sides by 10, y is equal to 4.5. Okay, and that's going to be inches because all of this is measured in inches, the perimeter. So that is the width. Okay, so 4.5y, y is equal to 4.5, and it's the width here. So to find the length, I'm going to use this equation right here. The length, x, is equal to 4 times the width. So x is equal to 4 times 4.5. So that would be 18 inches. All right, so the width is 4.5, the length is 18. We could double check to make sure our perimeter works out. 2 times 18 is 36. 2 times 4.5 is 9. 36.9 is 45 inches. So that does check. Okay, but remember, just reporting the width and the length isn't what we were asked for. We were asked for the area of this rectangle. So the area is equal to the length times the width. So that's going to be 18 inches times 4.5 inches. Okay, and 18 times 4.5 is 81. Inches times inches is inches squared. So the area of that rectangle is 81 inches squared. Okay, last example here. Once again, if you haven't worked on it, pause it and work on it. Otherwise, continue with me. Okay, so I've got the sum of the measures of angles x and y is 127 degrees. If the measure of angle x is 34 degrees more than half the measure of angle y, what is the measure of each angle? Okay, so I need to find the measure of each angle. So those would be, that'd be a good choice for my variables. So I'm going to let x be the measure of angle x, and we're going to let y be the measure of angle y. Okay, so what do I know? I know that the sum of the measures of angle x and y is 127. So x plus y is equal to 127. And then I know the measure of angle x, so that is x, is or equals 34 more than half the measure of angle y. So half the measure of angle y, 34 more than that. So I've got x is equal to 1/2 y plus 34. Okay, so now that we have our system right here, let's talk about how we would solve it. So I'm noticing that I've got x equals all this stuff right here. So I'm thinking substitution is a good method here. So I know that x is equal to 1/2 y plus 34, but I'm going to rewrite this. This is x plus y is equal to 12. Okay, and x is this expression. It's this one right here. X is 1/2 y plus 34 plus y is equal to 12. I'm so sorry. I don't know why I didn't have that 7 on there. X plus y isn't 12. It's 127. Okay. So that makes a little more sense. So I've got 3/2 y is equal to 127 minus 34. Okay. And so that's 93. Okay, now I want to get the coefficient of y to equal 1. And so I'm going to multiply both sides of this equation by 2/3. 2/3. Okay, so this becomes just y on the left-hand side. And this is 2 times 31 is 62. Y is 62. So what is y? Well, y is the measure of angle y. So if they both add up to 127 up here, then I need to subtract to find out. So so what I did was put it in up here. X plus y equals 127. So x plus 62 is 127. Subtract 62, and you get x equals 65 degrees. Okay, so those are the measure of angle x and y. And that's what we're asked, right? What is the measure of each angle? So y, measure of angle y is 62, and the measure of angle x is 65. Okay, so you will actually see systems of equations come up quite often in real life and in these problems here. So this is kind of practicing the word problems that we wrote way at the beginning of this module. We haven't been doing it for a while. So if you need help on translations, translating the English here into mathematical sentences, That's a good thing to practice, and you can find lots of practice in textbooks, on Khan Academy, different places like that. So it just takes time and practice to get good at it. Okay, so that is the lesson part of 29. So you have an exit ticket, you have a problem set, and you can work on that now or whenever is convenient. All right, see you soon.